Okay. And so we're discussing the chapter 11 of the Analyzing Baseball Data with R, third edition. And this one is about using a database to compute par factors. So let me first copy in the chat some, kind of accompany notes that gives you uh, additional sources and some bullets on some information that I found, relevant to the topic. So the learner objectives from the chapter. The first one is installing and creating a MySQL database. We're not going to go into detail on that. I revised the book and I follow the steps on how to create a MariaDB database locally in the computer, and it works. So, you can just go ahead and just, go through the steps. Then we're going to talk about creating a MySQL game log database and querying the database from R, right? Using, we can use SQL or we can use dplyr, the tidyverse. And then we're going to then get to the main topic, which is the par factors, building your own baseball database to compute those par factors. Okay. So the first thing that I wanted to, to show you is kind of an introduction to what we're talking about, these databases, or mainly relational databases. The acronym is RDBMS. So this concept comes from the 1960s. That's where the concept of databases was created. Then in the 70s, we start seeing what is called the relational databases. So what happens is that the database could be anything, could be, a collection of data in certain formats. But the relational databases structure this collection of data, it structures it into tables, rectangular format tables with rows as observations and columns as variables. Then in the 80s, they introduced, IBM, I believe it was, introduced the SQL, the structured query language, which is the standard, the de facto standard that we use for querying these relational databases. Then in the 90s, you start seeing the appearance of Oracle, for example, which right now it owns the trademark of MySQL, okay, and other organizations, and so forth. So in the 2010s, we have then in the 2000s, we have the internet coming into our view, and then in 2010, the APIs, how to connect with these databases remotely, etc., the cloud, hosting services. And then in nowadays, even though we have other types of databases, we have NoSQL databases, for example, we have unstructured the data sets. AI usually is very powerful, for unstructured data, just plain text, right? But still, in every organization, you will see this kind of database for the transactions, management. So why does the author introduces this concept when talking about, building a baseball database? Well, the issue is that, for example, the tool that we're using, R, it has a limitation, because the data that you are consuming in that environment, the R environment, has to be physical in memory. Okay. So if you ran out of memory, you cannot then ingest that size of data set. And that was true mainly around 4 to 5 years ago, because probably the laptops were not that powerful. Now we have more powerful laptops. And even the desktops, you needed about 8 gigs of RAM, etc., to try to ingest at least, a big chunk of data, for let's say 10 seasons of baseball data, or like the New York taxi, traffic that, with big data, you usually uh, getting into that, demo data set. So it's just millions and millions of transactions that we're trying to manage. So one solution that the author brings is to store that data into a database for consumption. Okay. So some of the popular choices, MySQL, like I said, Oracle now is the one that has the has the copyright now. That's why MariaDB, MariaDB came because MariaDB is the open source of MySQL. All right. Then you have also Postgre, SQL, and SQLite. SQLite brings kind of a simple way to interface, with a relational database. You don't need that much administration, etc. Just the data and, connect to it. Um, just a question. Everyone is aware of SQL. Have you used it before, or something new that I'm bringing to the table?
Yes, used SQL before.
Okay, good. How about you, Trevin?
Same here.
Okay, good, good.
The
So you
post
are SQL. For me, you are SQL experts. All right. So that makes my life easier. All right. So 11.2, once you install your database, right? The author chooses MariaDB. I chose Postgre because I wanted to see if I could hook up the GitHub repository that we're storing our notes to a cloud instance of Postgre SQL. I got into the instance, but then, when I found out that it was a little bit complicated to get the GitHub, connected to that because of security issues, then I say, okay, let's see, how we can manage that. So I had to make some arrangements to try to get it to the nodes. Okay, trying to store some of the data that we're going to use, etc. But because I have already the instance of Postgre, running, I can show you, I can demo, more or less the steps that the author is showing us in the RStudio. So the first thing that you do, apart from the libraries, okay, is to connect, create a connection to that database. That database is in the cloud, it's in a DigitalOcean hosting service, and those are the parameters, the ABDWR, that's from the book, but those are the parameters that we need to connect. I already did it, okay, so I'm not going to repeat it. And the way that you can see if you are connected or not is doing the class function with the connection. And you see that, yeah, we have a connection to a Postgre, uh, you know, server. All right. So once you get a connection, then what you have to do is try to build a schema, right? Build your structure of the database, of the tables, and then fill up those tables. And that's what the author between those sections is showing us, is portraying us. So this function, the retrosheet game log, what it's going to do is that it's going to go to this side, retrosheet, and it's going to bring the data from the game logs for the years that we decide. In this case, as an example, we can bring the game logs for the season of 2012 season. I already did it, okay? So for speeding up the discussion, and as you can see, if I do a glimpse using the tidyverse, I'll do a glimpse of that data frame, I get this, okay? So I get my columns, right, in vertical order, and also I get, the data for, in a kind of a vertical way. The ease is that instead of the head, that it brings you the columns, at the vertical. Now we're doing horizontal, so you can see the whole schema, okay? Um, So continuing, now the author is telling us, okay, now that you have, that instance and that retro sheet helper function, now we're going to create a table in that, SQL database. And the table is going to be game logs. So the instruction, what it does is that if the table doesn't exist, remove the table, and then we're going to create a new table with this schema. So this whole thing about the right table with the con, etc., is creating that schema for the ingestion of the game logs. Okay. Again, I'm not going to do it because I already did it for for speeding up the discussion. But if you do this, it's already the game is already there in the database. If you do this function, game logs, con, and table game logs is going to then create what is called like a pointer into our environment so that the game logs is going to point to that table, in the cloud. So we can call it as a data frame, but the game logs itself is not going to contain that in memory. It's going to contain only the necessary data that we need to connect to that table. All right. So if we do this, okay, let's see. Let's do let's do the head with the glimpse. So we see that in the game logs right now, they're stored 162 columns. We only bring the first 6 rows, and this is all the data, all the information that you have. All right. So if you do a class of the game logs, instead of a data frame, sorry, game logs. So if you do that, you see that this is the configuration of that, object. In other words, the data frame doesn't reside there. It resides in the cloud. And then what you're doing is just, pointing to it. So that makes it very efficient in terms of the memory consumption. You don't need to deal with those issues. So the next function that the author brings or writes is the append game logs. So this function is going to recursively use the retro game log function that we discussed before, but then we're going to, using the map function, we're going to then append game logs from different seasons or a range of seasons. So this is the way that it should be used. We're going to send a query. When you're communicating with the server in the cloud or locally, you're going to be using instructions like query, send query. So the query is going to be the statement in SQL that you want to run, and then you want to bring back the results. So in this case, we're going to truncate that table. We're going to do it now, okay? I'm going to truncate that table, and then we're going to use that append games log to map the function with a list of years from 1995 to 2017. Again, I already did it for to speed the discussion. So when we do this, when we bring out that ingestion from 1995 to 2017, what we can do is then run this query that what it's going to do is that the day is going to be in numeric format. We're going to bring only the four first characters of that string, which is the year of the season. Then we're going to count, from that year, we're going to count the number of games from the game logs. We're going to group it by year and then order by year. So let's see how this goes. Okay. Instead of sending the query, we're going to use the function getQuery now because we already have the query, right? The SQL statement, we already have the query. So we're going to send that query to the server and then bring back the results. Okay. And the results are this. You have the year 1995 to 2017, and you have the number of games, okay, for each of the year. Any questions so far? We're good?
Did those functions or what you ran earlier, did that take very long?
You mean
Writing the data
this
or
these functions?
yeah, downloading, did that take very long?
Not really. I mean, the functions are already in the, in the book. So it's just, running this. I mean, this map is going to run for a while.
Oh yeah,
This
that how
this one
long
is
did
going to
that
run for
take?
a while. Yeah, because you are bringing every season, you are bringing, to the server and then append, each one. So yeah, it's going to take some time.
Okay.
Okay, that's what I'm not running it right now. We're going to waste sort of 5 minutes of it
Oh,
of
gotcha.
discussion. Okay, so I already did that homework. All right, so we did the class of the game logs, and also we can check the game logs, the first the first records. Okay, and they start in 1995, 04/25, which is the start of the 95 season. One thing that you can notice is that when you have the data frame in memory, usually when you use that function glimpse from the tidyverse, you get the number of rows. Okay, here for some reason it doesn't bring it. But if you do a query on select count with an asterisk, in other words, count every observation, every row from the table, from the logs. If you do that query with the get query, then you get the number of rows. So that there are ways, to manage this. Okay, so let me see if there's something here. Okay, okay. So now we're entering in 11.5, and we're going to retrieve some data using SQL, some data from that table games log. And in this case, what we're going to do is compare the attendance of two Chicago teams, okay, the White Sox and the Cubs, by the day of the week since 2006 season. Okay. So the query, we're going to bring the date, the home team, the day of the week, the attendance from the game logs. The date is going to be starting the 2006 season because it's since the 2006 season. And the home teams are going to be the three-letter code assigned to the Chicago Cubs, which is Chicago National, and Chicago White Sox, which is Chicago American League. Okay. So here's the query, right? And when using get query in this manner, using that select statement, what you are bringing, the results that you are bringing, you can then store it in a data frame, immediately. Okay. So we're going to store it in chi attendance, right? And if you see the class, okay, of that object, it tells you that it's a data frame. So that is in the computer's memory, to do anything you want to do. And to check what are the results, the first 6 results, we're going to use slice head and then N6, and here are the first results. Now, one thing that the tidyverse brings is that you don't necessarily need to rely on SQL. You can use dplyr, for example, the dplyr functions, select, filter, arrange for the ordering, mutate, to create columns, etc. You can use that syntax to query your your table that is residing in the cloud. So the way that you would do it is this way, right? Doing the same thing that the SQL statement did, but using the tidyverse. Okay, and here to show you, that we get different results. Here are the same results. Okay, and also you can, if you are not sure, what is the exact format of that query, you can also show the query. In other words, you can use the tidyverse and then at the end pipe it to show query, and it will show you what is the query that the tidyverse is translating to then communicate with the server. The server is going to always look for the SQL. Okay, it doesn't understand the tidyverse, but the tidyverse can translate that to a SQL statement, and then the server can understand, then bring back the results. Okay. Any comments or questions so far? We're good? Okay. So, to get our feet wet, I did an exercise. It's not in the book, but I did an exercise of comparing the attendance of the New York, baseball clubs, the New York Yankees and the Mets, using the same technique, but then, giving you a visualization. So starting with game logs, I use the tidyverse, to get those results, and then with the ggplot package, then do a visualization. So in this case, this is the visualization that we have. All right. And as you can see a couple of things. For example, which club has more attendance in average during the week, the Yankees or the Mets? It's obvious, right?
Yankees.
The Yankees, yeah. All right. And for example, in the red, which is the Mets, right? You see that the attendance is the lowest on Wednesday. And, instinctively, you will see that in the weekends, the attendance will be higher. In the Yankees, probably the Tuesday is the one with the lowest, and then, the weekends. Okay.
While we're here, did you guys
Yeah.
grow up with like the American League being red and the National League being blue? Or am I just forgetting something?
I'm using the colors from the book.
Yeah, that's why I was confused because I felt that the book switched them, but I'm not sure.
Right. I mean, I can switch them, that's no problem. Okay, but yeah, but I'm using the schema from the book. Yeah, I mean, I don't know what the colors are from the leagues, really.
They both have their own logos. I think each has an eagle on it.
Oh yeah, okay.
Yeah.
To add to the confusion, right?
See yeah.
Right, right. I know that for history, the National League is the oldest. They're the first, one of the first leagues, and then the American, came after. That's according to history. But yeah, I mean, if we have some colors, let's see if we can improve this. Okay, so going back to the Chicago example in the book. Okay. Okay, got it. Sport logos by team. Okay, good. So here, what we're going to do with attendance in Chicago, what we're going to do is then convert that date, that numeric date, to a date format, and then replace, input the missing attendance numbers, because sometimes they weren't recorded with 0. Okay, so let's do that. Right? Don't worry about the error. It happens sometimes. And then let's recreate that plot that the book is showing us with the Chicago attendance. Okay. So here we are. And again, you can see very clearly, which team has the the largest attendance, right? Which is the Cubs. And here is the White Sox. And also, I use the bars, but here you can see that probably Wednesday also is the lowest attendance in average, for the Chicago Sox, and then Tuesday also for the Cubs, and also the attendance in the weekends, which is the greatest. Okay, so let's switch back to our notes here. I don't think we need our sequel anymore. Okay, so now we're going to get into the meat of the discussion, which is the park factors, right? And the first case that the author mentioned us is the Coors Field, right? And what is unique about the Coors Field that maybe is not unique or similar to other parks? Well, Coors Field is placed in Denver, right? It's located in Denver. And Denver, what is the moniker for Denver? Denver, the city of Denver? The high mile city, right? An altitude at least, 5,000 feet. And also, the weather conditions usually in Denver are dry. Okay, Colorado is like on a plateau, right? And most of the conditions are very dry. So that's a recipe. You can see that that's a recipe for the ball, in average, to carry a little bit further because of those, of those conditions, those environmental conditions. So keep that in mind, because we're going to, make an experiment on how, that affects the power factor in this particular field. Okay. Let's see here. Pepper raw.
Yeah, if you go up, you can see the
Okay. There you go.
purple row where it's exactly 1 mile.
Okay. Okay. I didn't know that. That's interesting. 1 mile above sea level. Yeah. Nice. Okay. Good one. All right. So what are the baseball, what is called the par factors, or at least the batting par factors, that's the one that we're going to be delving with? Well, according to the Wikipedia, the batting par factor is a baseball statistic that indicates the difference between runs scored in a team's home and road games. And this is the formula that appears in that article in Wikipedia. You will see that there has been some modifications to this, and the author doesn't use exactly this formula. He uses something similar to that, but in general is you take the home score on the home field by the home team and the visiting team divided by the home games, and then that you're going to divide it again by the road scores, away, the away team, etc., by the away games. And that will give you, multiplied by 100, that will give you the par factor. All right? So to test, this uniqueness that the course field has, we're going then to get some information about the Rockies, the Colorado Rockies, either at home or road since 1995. So the way that the author, gets this is using again the game logs that we have seen, with the previous example. We're going to select the day, the park ID, the visiting team, the home team. We're going to rename the visitors run score as AW score, away team runs, and then the home run score, rename it as home runs, HMR. And we're going to filter the home team, Colorado, and the visiting team, Colorado. And the day is going to be from 1995, which is the start of our data set. So when we do that, you get this glimpse of your data set, which has the information that we need to further our investigation. So the next step is to compute the total run score, which is adding the away runs and the home runs, and then creating another column that is going to be named course in this case, because it's going to be a flag for the games that are played in the course field or not. Okay? So here, now we have our two additional columns, which are the runs, the sum of the away and home runs, and if the game was played in the course field or not. Now, we're going to calculate then the par factors, right? For that, we have to go back again to our function, the retro. Well, not that function that we explored at the beginning. It's a function that is in baseball arc package. It's called is to retrieve that retro sheet data, because now instead of the games, we're going to see, we're going to retrieve the events, the play by play on the retro sheets. So we're going to do it from the season 1990 to the 1999. We're going to then get those events, okay, using the map function, using plug and events. And then with the database, you're going to then write to the table and bring back that as events DB. That is already done. Already did it here. To speed up the discussion. Okay. So the events DB is already here. Okay. And if you go events DB glimpse, okay, this is all information that it is in that table. Okay. Okay. So now we're going to do another query, selecting the away team ID. The home ID is going to be taken from the game ID because there's no home team ID. You have to grab it from the game ID, this one, the game ID. And as you can see, the first three characters are the the home team. Okay. And we're going to grab the events the event CD column. And we're grabbing on the year 1996, and the event CD is going to be all this. Why all those? Because those are when the batter didn't stroke out, or something happened that he hit the ball. Okay. And the one that we're really interested is in the home runs right now, because this is going to be kind of another runs part factor, but the home runs part factor. Okay. So here I did I did the query, did the HRPF, which is this data set. To make a run in the GitHub, I had to store it in the data folder, as an RDS file, to get it, not to get involved into querying the cloud server. Okay. But here in the HRPF, you get this. Okay. HRPF not found. Okay. Let me see. Okay. Now we get the HRPF. Hopefully. Yep. We got it here. Okay. Away team, home team ID, and the event CD. And the ones that we're interested is in the home runs, right? So each of the plays that are not, the events that are not 23, they're going to be in another column named was home run, which is going to be 0, but the 23 is going to be 1. Okay, and that's what we're doing here. So now we get our, was home run to start computing that home runs part factors. Following me, my guys? They're following? Okay. So now, with this information, we have to create 2 data frames. We're going to create the data frames with the mean home run, the average home run that happened during that season in the away games, right? In the away events, away games, and the ones that happen at home. So we're going to do that, right? EV away, events home. Okay. Then we're going to bind them. We're going to merge them, all of them, as a data frame called EV compare. And then we're going to pivot. So the format is going to be more of a wide format. Instead of a long format, wide format. So now we have each team, the average runs that they perform when they were away, playing, as an away team, and then the ones that were at home. As you can see, this formula is not the same that I presented, right? Because in that formula, you also, you were dividing by the home games, and also you were bringing, those runs that were scored by the other team. In this case, you are just bringing the home runs that you're doing home or away, and then the events, which is the denominator to divide those to get the average. Okay. So once you get that, then you get this formula, which is going to be the formula to compute the home run part factor, which is PF equal 100 multiplied by the average homes, and the average away. All right. So now, if we sort by that factor and get the first 6, look what happens. Which is the first one that has the highest part factor?
Colorado.
Colorado, right? Okay. With the part factor, let me show it here. Maybe it's going to be better to see.
Was there an indication that this was one of the first reports about park factors or similar to it?
Uh, I guess so. The thing is that the author eventually is going to tell you that this is kind of a simplification, exercise. So there are other um, parameters that you can use to compute the part factors. And you'll see that, for example, in the Savant part factors that we have, nowadays, because they computed with a 3 season range, you will see that those numbers are way higher than the ones presented there.
Good
Okay.
points. It also
Yeah.
surprised me that the Angel Stadium was the second most.
Right, right. But more or less, this gives us an idea, at least at that, at that time, at that season, which were the hitting friendly parks, and which were the not so friendly, right? So
Indeed, thank you.
yeah. So for example, the three, most friendly for the batters in terms of home runs are the Coors Field, the the California Angels, and the Atlanta Braves. Okay. But now let's see the other side of the coin, right? Let's see which are the parks that definitively, they are poison, to sluggers. So in this case, in that season, the LA, the Dodgers, the LA Dodgers were the park with the lowest RPAR factor, followed by Houston, and you'll see that in the exercise because I included one of the first exercise in this chapter. I included there, and it's kind of a similar exercise for the Astrodome. Uh, Houston also was one of the most you know unfriendly hitting home run hitting, and then the New York Mets too is there. Okay, so um, let me see, what time do we have? Okay, we have 15 minutes. So one of the things that I found, um, doing the research, okay, this is the event CD. You have the table of the events. As you can see, two is a generic out, for example. Eight is an error, but 20 is a single, double, triple, home run, and 23 is the one that we're interested in. That's Fenway. There's a discussion in the book about the famous green monster. Okay, this thing here, which is kind of close, to the home plate than the right field, and usually, for right-handed batters, is very friendly, very friendly. Okay, so here is a study that I found very, very interesting about baseball park factors more in detail. The guy is called Neil Wood. This is the YouTube video. Um, put in the chat. Okay. So he did, very, very well, very well research on different categories, on fly balls, ground balls, left-handed hitters, right-handed hitters, and different within the stadiums around the season 2017 and 2019, in that range. So very interesting, to get the feeling of the park factors. Another article that I found pretty interesting also is this one. Okay. This one is called "The Park Factors Are in the Pudding." So he makes an analogy between a refrigerator, what is inside the refrigerator, and a park stadium. And he goes by that analogy, to explain some things that are static, for example, dimensions of the park, the ground, etc., and other things that are transient. For example, if you go to a refrigerator today, some of the perishables are not good to eat, or some can last a little longer. The same way to the transient factors, the weather, the climate, etc., and of course, the altitude. Okay, so let's keep going to see how far we can get. So this is a plot that I got an idea from that YouTube video that I was talking about, the Neil Wood research. And it shows, from this data, right, from the EV compare, it shows you very clearly which are the parts that are, above the norm in terms of hitter friendly, home run friendly, and the ones that are, not that friendly. Okay. Usually the 100 is the average, the neutral part. And also I included how the park factors rating have changed, right? And this is from the Savant website. And as you can see, Coors still is in the, in the top. And, for as long as that part is open, because if when you close it, then you can change some of the atmospheric conditions. But as long as it's open, it's going to have that, that characteristic, right? You cannot change the altitude. Sometimes, the weather will be more drier, than humid, etc. But remember the part that we were talking about, the Dodgers, that were the lowest park factor. Now that price is with the Mariners, okay, Seattle Mariners, and also that park has certain conditions. For example, it's very humid, usually in Seattle, and there's some characteristic that makes that park a lot less friendlier than others. And as you can see, there are more factors here, not just the general par factor, but you can check the home run par factor and other statistics. Okay.
Yeah, it's interesting that
Yeah.
Colorado home run factor is only like 104 now.
Yeah.
And I think that's what we calculated from the book was the home run factor.
Correct. I mean, the home run factor in the 1996, it was about 158. It was very high,
Yeah.
very high. But here, yeah. And I know that the book also mentions that since I think 2002, they have been storing the baseball balls that they're going to use. They're stored in a humidity chamber. So trying to ameliorate that that bias that they have, right? Uh, but yeah, but still, it's at the top of the list. It's
And for the Dodgers, as you may know, from about 20 years ago, the
yeah,
ownership specifically removed some of their foul ground territory, added more seats, and made it more hitter friendly.
exactly. And you can see it right now. It's very neutral. The Dodger Stadium. Yep, yep, yep. I mean, probably that's the goal, for the whole, conference, for the whole sport, to try to, neutralize, these factors that they don't have that much bias, right? Uh, I mean, but sometimes, you can do so much. Okay, so let's apply the par factors, right? So now we're going not for the stadium, but for the individual performance. So the book chooses Andres Galarraga, right? In the 1996 play appearance. Where do you think Andres Galarraga played in 1996? Where do you think he played? Colorado. Okay. So we're trying to continue, that discussion from the course field to the player. So we basically do the same thing, as we did with the, with the stadium, right? We calculate the average home runs, etc., and we get for him a mean par factor of 128. So according to the author, and this is ad verbatim from the book, that mean PF indicates that Galarraga had his home run frequency increased by an estimated 29% relative to a neutral environment. So because he played most of his games in Colorado, remember that each team plays almost half of their games in their home team. Okay, from 162, 81, they're playing their home team. So that helps some of these players with their performance. Now, if you check in 1996, for Andres, that was the peak performance for home runs. He batted 47 home runs at that season. He never surpassed that. Okay, according to the baseball reference. Uh so yeah, I wish. Yeah. Right. He will be killing it. Yeah. So if you do this calculation, total the home runs for that season, 47, and then subtract by the mean par factor, which is the neutral par factor, you should have been hitting this, which is 36. Then playing at the Coors Field for Andres Galarraga help him with an additional 11 home runs, in that season. Okay. So do we have time for discussing that exercise on the Astrodome? Do you think, guys? Okay. So let me see if I think I missed something here because it's going to be, yeah. Yeah, let me give you, okay, home run, par factor, calculating basic pack factors. Okay. Yeah, there's a plot. Let me see if I skip it. Okay, here. Okay, here we go. So this plot, we missed it. Okay, but this plot basically compares that mean, that mean average, home run average, runs average, in this case, runs average with Coors and then the other parts. And you can see that there's a clear difference, right? Between the Coors Field, at least in these seasons from 1995 to 2017, the mean is way above, the rest of the parks. And also you can see it in this, bar plot when we aggregate all this, all this data, that definitively the Coors Field is, in average, is way up than the rest of the parks. Okay, so with that in mind, we're going to apply this same technique to the Astrodome. And we do the same thing, right? We get the game logs, we get the retro sheet, from the 1965 to 1999 season. In 1999, eventually the Houston Astros will move to another park. So 1999 was the last, season that they play at the Astrodome. Okay. So now we do the same analysis, and now we have this plot. So now you see that the story is reversed, right? Instead of the Astrodome being hitting friendly, now is the opposite, right? So you see the red as the Astrodome, which is below, almost below each of the other parks, or the mean runs of the other parks. And if you recreate that bar plot, volume plot that we use in the course, you will see that this is the Astrodome and this is the other parks, and you see kind of the difference. Not that much of a magnitude, but still a difference, not noticeable to it. Okay. And this is another plot that I, just was goofing around in terms of what is the delta of the parks. Each point represents a delta of, each other park, from the Astrodome. And as you can see, getting to a level of 0, you see all the points are way up. Okay, so the other parks are more friendly than the Astrodome. Only a couple of them are on the negative side. Okay. So that's what it's all about. Any comments, questions, jokes?
I don't think so. I I just noticed the Statcast Park Factor board.
Right.
It's 28 teams. And that's because the Rays and A's haven't played enough in their temporary ballparks.
Right. Yeah, and in the notes, I summarize some of the assumptions that the author mentions It's in
Mhm.
this. It's in one of the sections, 11.7. I don't know, but the assumptions, for example, there's some seasons where some of the teams played in different parks. Okay,
Mhm.
they played all the games in their home park. And as you can see now, the Rays are a case like that because the Rays are playing in the Steinbrenner, a field where usually they do their spring training because Tropicana, was destroyed by the storm. Uh, so yeah, so I mean, this is kind of a glimpse of what park factors are, but there's more to it. And as you can see, uh, there has been an effort to kind of try to alleviate those extreme numbers for the stadiums in general, and that's a good thing. Kind of leveling the playing field, try to level the playing field. All right, so that's a wrap.